ever do have questions, if you ever want me to send you the video, I certainly can, but I don't have to. You can go to YouTube and just search. It's on YouTube. Just search Treg and then Tracy Jaworski, my name, and it should come up. Okay. We don't get a link because you have to have so many followers to get a link. So, okay, let's try. Secant of t equals 2, and I know the sine of t is less than 0. Now that you really can't tell if it's on the unit circle, right? I mean, you don't have a good idea at all. So we definitely need to draw a picture. Okay. This tells me that y is less than 0. In which two quadrants is y negative? Quadrants. Pardon me? 3 and 4. This one tells me that sine is negative, so I could be looking at 3 and 4. Yes, I do need to narrow it down. Is it 3 or is it 4? Okay? Does that make sense to you? Remember that signage down here? Negative. We're either in quadrant 3 or quadrant 4. I do need to narrow it down. How do you think I can narrow it down? See where the x is. Well, what is secant? 1 over, remember I can't go on the video. Remember cosecant has that s in it. Cosecant is 1 over what? Sine. So what is secant? 1 over cosine. So is it positive or negative? Looking at this, is cosine positive or negative? Positive. So I want the quadrant where cosine is positive and sine is negative. Which quadrant is that? 4. So that's where I need to draw my picture. So it takes some thinking. So let's draw the picture. Something somewhere, and this is T this time, will tell you what quadrant it's in. Somehow, some way. Want me to go back over that? Oh, okay. And then you use SOHCAHTOA. So remember, secant is the cosine flipped over. So you come over here, instead of using adjacent over hypotenuse, what am I going to use? Hypotenuse over adjacent. So we know that hypotenuse over adjacent equals 2 over 1. And that's the way I have to draw my picture. The hypotenuse is 2, and the adjacent is 1. Any questions on that? Want me to repeat it? Okay. So let me just make this side y, because that's what we have to figure out. And we have to use the Pythagorean theorem. No shortcuts here. If you could use your primitives, then I would use it. If you can use your 30, 60, 90s or your 45, 45, 90 rules, I would use those shortcuts. But in this case, well, I don't know. Maybe. We'll check it and see. So we want to say y squared plus 1 squared equals 2 squared. So y equals plus or minus the square root of 3. Every time you draw the square root, or constitute that square root, you put plus or minus on it. So looking at the y right here, and it matches with this axis, would it be positive 3 or negative 3? Negative 3. I'm going to erase this and put negative square root 3. So I do think that would be, is that one of our long leg, short leg hypotenuse problems? 30, 60, 90 problem? So if you picked that up ahead of time, you would have been okay. Once you have the picture drawn, then the other 6 functions just come from the picture and using SOHCAHTOA. But do you have questions on this much? Okay, I'm going to erase this just so I can fit it up here. We want the cosine of t, which is adjacent over hypotenuse, 1/2. We want the sine of t, which is opposite over hypotenuse, negative root 3 over 2. We want the tangent of t, which is opposite over adjacent, negative square root of 3 over 1. So it's a lot, you have to persevere. It's one problem with a lot of easy stuff in it, but you have to keep going and going and going. Kind of like the Energizer Bunny. And definitely stay organized. Secant, we were already given, 1 over 2 is 2 over 1. Cosecant is this one flipped over. Keep the negative in the top. And can I leave a square root in the bottom? No, what do we have to do? Rationalize. So multiply by root 3. So that's the answer we're looking for. And cotangent is this one flipped over. Am I okay if I still write here?
No.
No. Flip your tangent over, so negative 1 over the square root of 3, but you have to rationalize. So we're looking for this answer. Any questions on that? So drawing a picture will work every time, but it's a lot more work. If we can get it from our unit circle, then we just take it off of the circle. Okay. I do want to go over some things on your graphing calculator if we could. Some calculator work, I guess, because you're going to have some problems like that. So let's make sure we're in radian mode. And I want to find the sine of 2.2. So I just need the 0.8, what is it? 0.81, can I get confirmation? Everybody getting it okay? 0.81. Usually, Let's report that out with 4 decibels, so 0.808, is it 49?
49, yes.
So let's use 5, okay? Try the cosine of 1.1.
You want 4?
Yes, please.
0.4536.
Okay, can I get confirmation? Yes, okay. Now, if I want to do the cotangent of 28, I need to do 1 divided by tangent 28 on the calculators.
Negative 3.553.
Sure. Okay, confirmation. Rounding looks good. Is it going okay? Okay, and if you want to do cosecant, what do you think you have to do? Ooh, careful, what is cosecant? 1 divided by sine. I didn't put the number up here, but the cosecant, we don't want to use t, we want to use, let's use 98. 0.98. It can never be more than 1. It can never be greater than 1, or it's going to give you an error message, I believe. What do we get?
1.2041.
Confirmation? Okay. So in a story problem, they're just going to tell you what function to use, like cosine, sine, or whatever. That means just pick up your calculator and use your calculator, you know. If you're in a hospital working or on the job working someplace else, you know, they're not going to whip out their unit circle. They're going to use their calculator. So in real life problems, you need to just use that calculator, because you're going to have a few of those problems today. Okay. The year that I had Serena, Tyler, and Treg, she knew an engineer person that had the unit circle actually tattooed on their arm. So engineers use the unit circle quite a bit. Yeah. Yeah. Makes life easier if you know it. Okay, so here's your homework assignment. Now I'm gonna see you right away tomorrow, but if you can get to this tonight, because tomorrow night's volleyball, and we all want to go to that, so try to get to it tonight.
Kylie, is it here? Maybe I'll go home and come back. I got you. Oh, dude. I have to work tomorrow.
Let me just explain these problems. Okay. So 81 through 84 are those story problems I was talking about. So you're just going to use your graphing calculator on those. Make sure you can kind of tell when you're reading through the problem what it